Good evening, everyone, and a very warm welcome to the Engineering Faculty Field Specification Awareness Session 2026, organized by the Engineering Faculty Student Union in collaboration with the Department Student Societies. Choosing your engineering field is one of the most important decisions you will make during your university journey. It shapes not only the next few years of your academic life, but also the career path that you will pursue in the future. Over the next two evening, you will have the opportunity to hear from accomplished industry representatives and experienced PhD researchers from each department who will share their knowledge, experience, and valuable insight to help you make an informed decision. So, whether you already have a dream field in mind or still exploring your options, we encourage you to ask questions, stay curious, and make the most of this opportunity. To begin the session, I would now like to invite Mr. Kishan Chamit to the of deliver the welcome address. Mr. Kishan?
Thank you, Situ. For the organizing committee, I warmly welcome all of you to today field specification session, organized especially for the 25 batch. First of all, I would like to thank all of our speakers and welcome them to the our session, and also huge thanks for the engineering department societies for the supporting in organizing this session, taking the time to share their valuable knowledge and experience with you. As you all know, your field selection deadline is near. Therefore, we understand that this is a very important decision for all of you. The purpose of these sessions is to give you better understanding of the different fields before you make that decision. Throughout today and tomorrow, you will have opportunity to attend these sessions covering the different fields and hear directly from the professionals and experienced individual in those areas. They will share insights into industry opportunities, career pathways, research opportunities, and academic opportunities available within each field. Today we have four sessions, and tomorrow we have also four sessions. So I strongly encourage everyone to make the best use of this opportunity. Listen carefully, ask questions, and try to understand not only what you can study in a particular field, but also where about that field can take you in the future. I hope these sessions will help you gain the clarity and the confidence you need to make informed decision about your field selection. Once again, I warmly welcome all of you and sincerely thank you for speakers and everyone involved in the organizing these sessions. I wish you all a very productive and insightful session. Thank you, and let's start. Siduli, over to you.
Thank you for your warm welcome and insightful thoughts. Our first session this evening is with the Department of Biomedical Engineering. So I would now like to invite Mr. Chamit Dilshan Ranatunga, PhD student at the University of Melbourne. Mr. Chamit, over to you.
Hello, am I audible?
Yes, sir.
Okay, just give me a second.
Mr. Shamit?
Hello, yeah, can you hear me?
Yeah, I can hear you.
Right, okay. Sorry, I just joined the meeting. It was supposed to be 11:40, right? Sorry, 7:10. Okay, right. I'll share my screen. In case what I missed, can you repeat what you guys were talking about? Because I just joined the meeting.
We are just starting the sessions.
All right, okay. Right. Okay, sorry. Can you see my screen?
Yes, we can see.
Okay, cool. Right. You can see the slideshow, right?
Yeah.
Right. This, I think I am talking to students from 25th batch. Hello.
Yes, sir.
All right. Okay, cool. So first, I should thank you all, the organizing committee, for inviting me to conduct this small session for the juniors. So it's I'm honored to do this session, and also I should congratulate the students for getting selected to University of Moratuwa. It's a huge achievement in your life, and now it is your time to get the best out of it and develop your future career. So if I talk about the BME research, biomedical engineering research, uh, first you have to understand what is biomedical engineering research and what we do here. What we do here is we connect engineering principles with medical sciences to build new tools and devices that and also systems that improve human health and healthcare. So this biomedical engineering research domain that divides into several subsections of biomedical engineering called biosignal processing, biomedical medical imaging and medical image processing, and also biomechanics. Like there are different branches that you can go in different directions. So one of the main area biomedical engineering research happening is biosignal processing related. I'm doing my PhD in University of Melbourne here in Australia, and my PhD is based on this biosignal processing. And for an example, to get you guys an idea about what research happening in biosignal processing area, I will show you a quick video. In this video, a person who cannot speak is trying to think, like trying to imagine speaking, and a machine is trying to decode what that person is going to say. So this is a very good example for biosignal processing related research. I'll show that video. can you confirm whether the sound is audible to you guys of this video?
No, sir.
Yes, it is audible.
Oh, it's audible, right?
But it's better to increase the volume, I guess.
Okay. I think this is the maximum. So this audio is not that much clear because this person is not a person who can speak like us, like a normal person. So he's trying to speak this sentence. The sentence says, I never want to go back there. But you can see like he cannot speak, but we have sensors attached to his head here. And through those sensors, through those sensors, we try to decode what is he trying to say. So this is a good example for biosignal processing related research. Actually, my research is in this domain. So from the video you heard, that sound is very flat and it's robotic, it's not natural. And what I'm researching is to make this speech more natural and give prosodic information to that speech. Like, for an example, the tone, like how people change their voices. Those things, those advanced research is happening in this biosignal processing related research domain. I'll play that video again just for you guys to check this. Right. So then I told you in this biomedical engineering research, there's another field that is medical image processing and medical imaging and medical image processing. Here I'm showing like a deep learning model trying to identify abnormalities in say X-ray images or MRI images. So I think you guys have heard about MRI images and X-ray images, CT scans. Those images and how you build machine learning or deep learning models on top of those images and how you process those images, that belongs to the research domain that comes under medical imaging and image processing. And another branch of biomedical engineering research is biomechanics and rehabilitation engineering. So yeah, this is a well-known figure. It's Muralidharan. You know that he was from ICC, there was a complaint that he's chugging, and therefore they conducted some tests on him. Like you can see here, there are some markers on his body, and then they are trying to map like how his movements are happening. So this kind of research based on biomechanics field, and also there are this, you can see this rehabilitation thing. Helping people that who cannot move their limbs, these kind of things comes under biomechanics and rehabilitation engineering. And also there's another very special domain, the special branch of biomedical engineering research, that is medical instrumentation and wearable. This is a cochlear implant you are seeing here. So you have seen that people who cannot hear are using these cochlear implants. So it will get the audio signal from the outside and amplify and feed it to it stimulates your nerve ending, so you can hear that again. So and this image I'm showing here is an electrode, and this is supposed to go inside your body to collect your body related signals. And these kind of designs, those happens on the medical instrumentation and wearable. And also this one is from Galaxy Ring. This is the Galaxy Ring from Samsung, and it's also falls under the wearable research section of biomedical engineering research. And also in this biomedical engineering research, there's another branch called tissue engineering and biomaterials. Actually, since I'm from 19th batch of University of Moratuwa, the time we learned, there was no special lessons about tissue engineering or biomaterials under our syllabus. But I do think in the new syllabus, the subjects are changed. Therefore, there might be a chance that anyone who is willing to do tissue engineering and biomaterials to get a chance to go in this direction as well. So now let's talk about the research opportunities. These research opportunities I can mainly divide into two sectors. One is academic research and the other is industrial research. When you first hear about research, like most people will think it's just academic, like doing a PhD or an internship. But there's another thing like that is industrial. So under academia, what people try to do is to get some novel like scientific discoveries and then come up with academic publications targeting peer-reviewed journals or conferences. And on top of that, most of the time, researchers try to build spin-off companies. For an example, from my lab here from the neurobionics lab from University of Melbourne, there's a spin-off company called Fluent. The main research the founder did during his PhD is building a subscalp electrode. That means an electrode that can go inside your skull and collect data. And now using that electrodes, they are around that research, they are building an industry as well, like they are building a company called Fluent. So yeah, academic research focuses on the scientific discoveries and publishing them, while industry research try to adapt those discoveries and make a commercial product out of that. And the companies also publish this research, like not only academic field publishes research, industry as well publish research. Actually, it's good that I could talk about this because I have been in both these research sectors. Just after my degree, I joined industrial research at a company called Brain Gas from Spain. And in that company, like we tried to build machine learning models that can identify ADHD patients and autism patients. It was a good experience for me before going to the academic research. So if anyone is thinking like just after graduation, what should I do? Like, should I go to academic research directly or industrial research directly? Like, what I have to say is by doing the degree at biomedical engineering here, like you have the opportunity to go in any of these paths. Like if you want to first go to academic research, you can first go to academic research. If you want to go to industrial research first and then go to academic research, that is also possible. Because some of my friends directly came to academic research, they started PhDs, but I chose a different path. I first went to industrial research and then came to academic research. Yeah, research internship opportunities and research PhD opportunities I should talk about. When you are doing the bachelor's degree, in your third year, you have to undergo an industrial internship program. That internship program gives you the experience about like how the industry behaves. But some people choose to go for universities to do their internship. Like it is still valid under the industrial research category. So I did my internship in Singapore University of Technology and Design, and my colleagues did internships at University of Sydney, and I know some juniors who did internships at University of Melbourne here and Monash University, NUS, NTU. Like you have the chance to go to any of these universities, and plus more universities. I have only listed like few universities here to get to do a research internship, and it is very possible when you are doing biomedical engineering for your bachelor here in University of Mordo. Because the thing is, biomedical engineering degree is the degree that most percentage of people go to research internships or overseas internships, and as well as the PhD opportunities. For internships, brain case, my previous company, we offered a lot of internships to biomedical engineering students from University of Moratuwa continuously for 3 consecutive or 4 consecutive years. So these companies and universities have a direct link with the university, with the biomedical engineering program at the moment, because of the previous researchers or previous students who work with those companies. Like they left with positive uh, positive conclusions, right? And for an example, talking about the PhD opportunities, in my batch there were 16 biomedical engineering students from 19 batch, and out of those, 6 people are doing their PhDs at University of Melbourne only. Out of 16 people, 6 people doing their PhD at University of Melbourne. And for an example, like the people in our lab here in the University of Melbourne, like they think, they say, like University of Melbourne feels like a, a small part of the University of Moratuwa here, because that is the connection we are like, the trust we have built through the biomedical engineering program in these universities. And also another student from our batch is doing his PhD at University of Loughborough, England. So out of 16, 7 people are now doing PhD research. Those are the things I had to discuss, and I think other than this, I wanted to talk about the final year research programs. I couldn't make a slide because I actually made all these things at the last moment, because I was very busy, and I it was a very short notice for me. So I should talk about the final year research, because in your final year you will get a chance to work for a 1 year long research, and that research also will broaden your research capabilities, and it will give you a chance to work with your seniors, get support from them, and get support from supervisors from different countries or different universities. Therefore, it's a good opportunity for you guys to like get research skills, because as I know, it is not mandatory for other departments to do a research-based final year project, but for biomedical engineering students, it is mandatory to do a biomedical engineering uh, to do a research related final year project. So you have that chance as well if you come to biomedical engineering. So if you have any further questions, if you need to contact me, you can scan this QR code to get my contact details. Uh, I might share this presentation slide with you guys later. So then you can find my contact details from this QR code. And thank you. If you have any questions, please feel free to ask me now. Hello.
If you guys have any question, Please drop in the chat. You can unmute yourself.
Okay. I have a question. Someone has asked me, can you please mention about salaries? Yeah, the thing is, okay. Can you please mention about the salaries? Okay. The thing is, biomedical engineering students are getting they are among the highest paid from Sri Lanka. Sorry, from University of Moratuwa. For an example, like software domain related companies earn the highest salaries usually in Sri Lanka, but if a biomedical engineering, so when you're doing biomedical engineering, like you have the companies know that you have the capability of going to either in the software domain or either in the electronic domain or in machine learning or deep learning domains. So therefore, you will get chance to work in any of those, like in any of those fields at the end of your degree. But if you're going for the research domain, if you work for a company while being in Sri Lanka, you will get a good pay, a very good pay. Am I supposed to like say about the ranges? Like, do you guys need to know the ranges? Okay, talking about ranges, like you can start with at these days you can start with 4.5 lakhs per month. You can start with if you land on a correct job. Yeah, by doing this degree program. And one is asking, like, can we go for electronic jobs in Sri Lanka from this stream? Yeah, I know people who went for electronic jobs by doing this stream. It's possible because you get the experience to work in the electronics as well, because you will be building some electronics. You will be engaging in some electronics related projects as well. Like for an example, I mentioned to you these medical instrumentation and wearable. This is mostly engaged with electronics. For an example, like we built ECG reading machines and EMG reading machines, like that. So you will have the chance to get some electronic knowledge and therefore electronic jobs. And one is asking, BME has no Washington approval, how it costs when go to a broad job. So far, I haven't heard of anyone who had a problem with not having Washington approval. And I think the university is in the process of getting the Washington approval as well. Yeah, I haven't heard about anyone who's having a problem, but I know people who are working abroad. Therefore, I don't think it's a matter. Like most of the time, like if you go for a research engineer position or a software position or something, like most of the time what they will look for is your projects and your skill set. So therefore, the Washington approval, I don't think it will be a problem, and I haven't heard of anyone. One is asking, do you know, are there any material science engineers working there in your research projects? Are there any parts related to MSc engineers? Material science engineers, I think they can work in this tissue engineering and biomaterials related field. And also I have seen some research about like different kind of electrodes and for an example here, this research, the second image here, that is a tiny electrode that is supposed to go inside your body. And when designing such electrodes kind of things, like, you need to have some material science knowledge as well. Therefore, material science engineers can contribute to biomedical engineering related research from that aspect.
Mr. Chamit,
Yeah.
due to our time constraints,
Oh, right,
it's
sure.
better to proceed to our next speaker.
Okay.
So, thank
I
you
have
very much.
yeah. Just give
Thank
me a
you
second.
very yeah.
I have several questions, but what I can do is I'll answer to these questions then as private messages. You can move to the next speaker. Yeah. Because through Zoom, I'll reply to these students. You can move to the next speaker. Thank you so much for providing this opportunity to me. And it's
And
glad.
thank you very much, Mr. Chamit, for your insightful presentation and sharing your experience with us. And and our next speaker, also from biomedical engineering. I would like to invite Mr. Digmendra Nagahapitia, Head of Research and Development at Verox Labs Private Limited. Mr. Digmendra, virtual floor is all yours. Mr. Digmendra.
Hi, good evening to everyone. Hope I'm audible. Am I audible?
Yes, we can hear you.
All right. So let's start. So I'm really sorry that I don't have a presentation prepared for you guys because I'm in the middle of a bit of a family emergency situation. So I didn't have much time to prepare anything. But what I would like to do is to speak a little bit and then answer a few questions. So my task today is to speak about biomedical engineering from an industrial perspective. And I'd like to pick up just from where Mr. Chamit left, because he was talking the right points, and he already covered the aspects of biomedical engineering, the research and all. So in the industry, and he also touched on about the salaries, the opportunities as well. So I'd like to extend a bit more on those points and give you guys a little bit of an insight on how the industry operates in terms of biomedical engineering. So a bit about myself. I'm currently working as the head of research and development at Verox Labs Sri Lanka. So Verox Labs is a medical device company. We basically make laboratory devices for in vitro fertilization. That means test tube babies. So our products are in about like 50 countries. So all of them are designed and developed by our engineers. And I'm happy to say that we got, including myself, there are 3 biomedical engineers working at Verox Labs, and also 2 mechanical engineers. All are from University of Moratu. So that's the glimpse of the opportunities that you're gonna get when you follow this degree program. So biomedical engineering is a really interesting subject, and when you tell someone that you are studying biomedical engineering, they might ask you whether you are studying to become a doctor. But the reality is that uh, you are indeed in between 2 very special fields. One is engineering, and the on other hand, there's the medical aspect. So you need to kind of master both these worlds and understand the the the, the consequences of medical aspects as well as engineering aspects. So for example, you all know about smart home systems, right? There are IoT systems where you can automate your home, you can automate your lighting, you can open doors, close doors, do all kind of things. So now apply that, let's say to a hospital where life is critical. So you are saving lives, but you are monitoring the life. So that's it's still IoT, but the application is different. So that's just a simple example of what biomedical engineering is in the industry. So I'd like to say this point because someone asked about the salaries. So according to what I think is that um, when you select a career path, uh, you should not focus on the salaries first. What you should focus first is to discover yourself and identify what your passion is. So if your passion aligns with a particular field, you must choose that path, and then only you can go uh, work up the ladder. Otherwise, whatever the field you're going to choose, if you're only selecting that particular field based on the salaries, you're not going to get satisfied. Because I believe that people work for two reasons. They either work to get paid, or they work to get intellectually challenged. So that's a spectrum. You either get paid or you get satisfied. So biomedical engineering is a very special field where you get the best of both worlds. You get a very good compensation as well as a very good satisfaction. When you want to have a higher degree of intellectually challenge, you choose the academia. And when you want to be updated and be on top of problem solving as well as getting well compensated, you choose the industry. That's the simple truth. So if I'm to talk about opportunities in Sri Lanka, we got companies like us, Verox Labs, and then we got Synergen Health, which is a leading healthcare um, service provider for US, and it's based in Colombo. And we got a lot of engineers from University of Moratuwa uh, leading the core electronics, software, machine learning aspects at Synergen Health. And then we got companies like Effective Solutions. They started as a startup from the Department of Biomedical Engineering, and now they are going for these FDA approvals, and they have, which is tailored for detecting cardiovascular disease. So you see, you get to save lives. When you become a doctor, you save one patient at a time. When you become a biomedical engineer, you get to impact a lot of people. So and then also we got companies like WaveTech. I think that's a subsidiary of MAS, and there you get to work with wearables. So these wearables, you get these EEG ECG signals like Chamit showed you early, and you get to work with this biosignal processing, do something life-saving like tracking the heart rate, the heart health, or something like that. So there's a very vast range of opportunities that you get when you step into biomedical engineering. And also, I'd like to touch on another point Chamit mentioned, that when you study biomedical engineering, that this particular degree program is tailored to uh, cover a very vast area of knowledge. So you get to study electronics, software, computer systems, network systems, um, embedded systems, robotics, machine learning, all these things. So biomedical engineering students get a lot of opportunities in Sri Lanka as well as abroad just because they have a high capacity. And if you are ready to cope with that level of high capacity, this is the place for you, because you can work either on electronics, or you can choose software, or you can go for machine learning, whatever. People know that, uh, in general, people know that anyone from the Department of Electronics and Telecommunication are really good at problem solving. They know that these people are critical thinkers, so they get a very good opportunity in landing jobs in Sri Lanka as well as abroad. So um, this just what I want to talk, and I'd like to now move on to questions. And with questions, I think I might be able to answer, like give more information about this field. I think about material science engineers. Is there no worth for material science engineers? How you decide the material you want to develop? Okay, so this is a very interesting question, because don't box yourself. When you come to the industry, if you box yourself as, if you label yourself as a biomedical engineer, electronics engineer, software engineer, then you is something that gets updated every other day. You cannot box yourself in one corner and say, I'm a biomedical engineer, I don't know anything else. You can't say that. You need to stay updated. You need to become what I call a T-shaped engineer, because you need to know a little bit of everything. While you master a particular field, you need to know everything else. So material engineers are really important for biomedical. There's a specific field called biomaterials. I think they teach that subject in I guess the third year or fourth year. There's an optional elective, optional subject. So biomaterials is equally important. So materials engineers are really important aspect of biomedical engineering. Any other questions? Also, while I get another question, I'd like to show uh, a bit of like what we do, because that's the only thing I can show you guys. So let me just share my screen. Yeah, now this question is also going to align with what I'm going to show now. So describe a project that my team and I are doing right now. So so here's a project. Here's the project that we are on right now. So this is a project called Metro Genie. Hope you guys can see the screen. So I said we are working in the field of in vitro fertilization. And if you know what in vitro fertilization means, it's all about making test tube babies.
Mr. Dikmendra, we cannot see your Thank you very much, Mr. Nagapitiya, for joining with us and sharing your insights and expertise. So, moving on, our next session features Department of Chemical and Process Engineering. And our first speaker is Mr. Madhuragavan Pravindran, Shift Manager, CT, Agarpatana, Unilever, Sri Lanka. I would like to invite Mr. Madhuragavan to feature in this session. Over to you, Mr. Madhuragavan.
Okay. Good evening, everyone. Am I audible?
Yes, you're audible.
Yeah. Okay. With short period, it is short period of inform. I think I prepared a very simple presentation just to deliver the content. I'm audible, right?
Yes, now you're audible.
Yeah. You can see my screen also, right?
Yes.
Yeah. I just wanted to deliver the what is this is basically the chemical and process engineering with the three simple separations categories. The first one is what are the fields which we are going to work and what are the fields which are available and what are the local Sri Lankan opportunities that we have now, and as well as how the global and other research path opportunities are there. First of all, currently my name is Madhuran Ravindran, and I'm currently working as a shift manager in CRT Agrapadhan plant, and it's a Unilever Sri Lanka Limited. And here I have mostly my major role is to run the overall production as well as to handle the engineering department also. Here, from the lecture hall, we have we have designed or studied so much of things, but in real industries it is so much of different, as well as it give the running of the live plants. Here what makes us special, because we can call ourselves as a universal engineer, because our chemical and process engineering is not a core engineering field, it is an applied science engineering field where we optimize as well as interrelate with the other engineering aspects also, like mechanical engineering, and we have to know the basics of civil engineering, and we have to be well thorough in electrical engineering, process control aspect also. Here, because we are our scale is so much of a bigger picture. Here, we have to think in all aspects, because if we change something from one thing to other thing, we have to focus our overall consequence throughout the plant as well as the operation. So, and our major portfolios depends on our scale, because here from the lab reaction, we have to scale up to 1 million units of units with a safe operation and efficient operation with a profit we can achieve. Because even though we can be technically so much of sound, but if we can't deliver that thing with a profitably as well as a feasible way, we cannot successfully deliver our work towards the society. And here we are the problem solvers by design. Here we have to think about the overall heat, mass, momentum, reactions, as well as toolkits and other digital tools, as well as we have to consider the process optimization tools. And nowadays we are optimizing the machine learning into our overall core object to deliver very efficient deliveries. And our scope will be a very wide scope, and our demand will be always there, because we can be overall we work in energy as well as the water purifications and food and medicine, and we are work in several areas where we can go for so much of opportunities will open up every day. And these are the core fields that you can interrelate with the chemical engineering. Here, even though you do in a chemical engineering degree, in final, you have to choose a field and go to a specified field. Here, the petroleum and petrochemical industries, because most of the time, if you say a chemical engineer, most of the time correlate with us petroleum engineer, but it's a separate field. But we have the potentials as well as specialization to go to work in upstream processing as well as downstream processing also. In power generations, the steam engineering also, we have alumni as well as our recent graduates have the opportunity to work with. In environmental aspects also, we have the opportunity, because in overall as a way, the world is going towards the sustainable way, where we are going towards the sustainable solutions for every problems we face. Here, with the environmental aspect, it's include the wastewater treatment, solid waste management, as well as the other air purification, carbon capture technologies. All the thing will be in environmental resource protection area. And in the renewable sector also, we have the opportunity, because with the rising demand of the energy demand, we have to switch towards the renewable energy. And in the renewable energy engineering also, we have the specialization field. And we can work in the food and beverage processing also, because in Sri Lanka, most of the industries are mainly in food and processing, food and beverage processing. And in the biochemical aspect also, with the industrial scale processing, like if you can take the vaccines or any kind of thing, which is very much of prominent throughout the COVID pandemic period. If we consider, if you develop anything with the lab scale, you need a processing engineer to upscale it and to produce it in a large scale. For producing in a large scale, it contains so much of problems, and you have to manage this all. These are the key pros of our field. And the pharmaceutical industry, here in Sri Lanka also, you could have asked about the Helion as well as the SPC. Those are the pharmaceutical industries which can be taken as an example in Sri Lanka. In electronic and photonic device processing, we have the potential to develop the polymer which will be used to do the semiconductor as well as to other polymerized problems. Here in local industries, we don't have that much of technology yet, but in foreign, we have so much of opportunities, because to process and to deliver a microcontroller as well as any kind of semicontrollers, you need a processing engineer. In polymer engineering also, you can take example as tire manufacturing or any kind of plastic. The most of all the things you are using now contains polymer. Even the laptop overall built frame and all the things are polymer. And computer processing, you can take the optimization, the process optimizations as well as process modeling aspect also. We have the options. And if you take the textile engineering also, you can call our Mars as well as Brandix, and most of our past alumni are working there. And since you have got to know about, we have so much of industries to work on, and we have so much of opportunities to go with, because with the broad field variations, you can choose a path which are very feasible for you all, and to grow in that. And it's more, there are more opportunities nowadays with the growing of our Sri Lankan economy as well as the world technological advancement. You will definitely get a chance to work on with the engineering field. And we don't have a border. You can even work in Sri Lanka or go for foreign or any global aspects also there. And these are some of the Sri Lankan opportunities that is available now. I already told that food and beverage is our main industry in Sri Lanka. Here you can you have got to know about these of the companies: Nestle, CBL, Maliban, Fonterra, Ceylon Cold Stores, and Prima. And these are not the only ones, because these are some of the prominent examples that we can point out. That's why I mentioned it here. And in a chemical and material, you all got to know about the Hales and Continental Tires, Michelin. These are the polymer engineering where we are working on. And the Alumex, PGP Glass, Asian Paints. These are the other opportunities which are open to us. And in pharma and as consumer, FMCG, fast-moving consumer goods, Unilever is one of the world international company, as well as the Hemas. Hemas also international one. And the SPC, our Sri Lankan Pharmaceutical Corporation, DSI, Rhino, as Adamdi Lukmanji. And if you consider a field which are not related to production and any kind of thing, and you want to do in a energy optimizations or environmental aspect, you can go into these kind of field, like Inzi Cement, Melwa, Ceylon Petroleum, and Waste Value is one of the consultants company where we can, they are the prominent company, Industry Solutions Sri Lanka. Those are the two prominent companies nowadays towards the waste solutions in Sri Lanka, which is a very growing field now. And what about the abroad opportunities? You can go either on the postgraduate study path, or you can go for industries. In postgraduate study path, you can go for MSc, PhD, or higher studies. And some of the prominent and the famous among our department was NTU Singapore, as well as Melbourne University. And in the oil and gas energy industries, the Middle East, as well as the Middle East is the prominent one nowadays. But with the upcoming energy developments in the Europe, also in Norway, and other offshore petroleum excavation fields, also there are opportunities. And in the research and R&D, we can, since we are chemical and processing engineering are a combined field, with the chemical engineering aspect, we can go on a research and R&D aspect and go for R&D projects or in work on R&D fields. And in global aspect, the pharma and FMGs are the most of the prominent fast-growing industries. Some of the examples will be the Nestle, Unilever, and with the strong engineering foundations, where you all get a chance to work on this industry. And we have three major pros here, because it's the widest field of engineering, because you have so much of career paths and so much of field specifications. So you can go in where any of the field which are very interesting and which creates your passion. And there are real jobs in Sri Lanka also. And there is also an opportunity in abroad also. So I would like to, if there are any questions, you can ask. So. Yeah, in petroleum engineering aspects, currently we are having LAFs, lubricants, as well as Ceylon Petroleum Corporations are prominent petroleum side fields in Sri Lanka, because even our alumni are also working there. You can reach out for them if you need more about the process as well as the work life, how the work life aspects are there, and to reach out there, you can go for that. And yeah, as an entrepreneur, yeah, in entrepreneurships also, since you have the overall product developing as well as the all the core aspect to develop the process as well as to continue the process flow, you have the chance to be a better entrepreneur when you start a new business or to supply any kind of thing. In entrepreneurship, you can start a consultancy company also, because you don't need to start anyways a business or any kind of thing, or you can go for the consultancy site also. And no, It's a myth because you won't work on fully on chemistry. The most of the major part was related into physics because you have to go for fluid dynamics, thermodynamics, and all the core mechanical modules which will be you will study if you choose a mechanical engineering studied in chemical engineering also. And salary range. For initial roles, the salary range might differ, but it depends on the role as well as your skills. Because if you be a one person, a unique person, and as well as you with the current technologies and other growing skills, you have the better salary packages. And there's an opportunity because in your internship, you can build your own chances because in intern you will get a chance to work on there and get the proper recognition. If you perform well in your industrial training, you will stand a chance in your first job as well as in a better salary scale. In overseas, the pay scale is so much of higher, but the one of the barrier we are facing is as a first job to get the foreign job, it's a little bit difficult because in the industries, in foreign industry, they might ask for experience prior to working on an industry in a high scale industry. For that, it's better to get a proper experience and go for foreign opportunities. But if you are very much of skill as well as very much of potential, you can get the first job in global aspect also and get a large salary scale deviation from Sri Lanka. Yeah. In entry level, you might expect I can't say a specific value because it depends. Yeah, in food and bioengineering aspects, most of the industries we are in Sri Lanka are food and beverages as well as the FMCG manufacturers. And you might get entry level packages from 1 to 2 in range. It's an entry level package scale, but you can't say it's below because you will get a chance to get the more of that scale. The responsibilities, if you take the manufacturing production side, you will have to take care of the overall production as well as the manufacturing engineering responsibility as well. But if you choose the other things like wastewater or energy kind of thing, you will get the analyze part as well as the RCA part. And yeah, you can change the path at any moment. Yeah, you can get the PhD opportunities, and Lasan Aya will tell about more about the abroad higher study scopes. And yeah, there are focus areas, and you can get your focus areas in between. After third year, you will get a chance to choose your own field. No, GPA doesn't matter because you can get a job with any kind of scale of GPA. Yeah, it's manageable. It won't be a intense one. And Hari, okay. Then I sure I will finish my session now. Thank you.
Thank you very much, Mr. Madhuragavan, for providing us with a great understanding of chemical and process engineering. Moving on, our next speaker is also from TCP. I would like to invite Mr. Lasan Manojithalian again, PhD student from Texas A&M University, USA. Mr. Lasan, floor is all yours.
Thank you. So I'll just go ahead and start it right ahead. I just want to tell you before I start that I am biased about coming to other countries, especially USA. That I feel like your opportunities as a university student at University of Moratua, you have much more capacity and potential to earn and to experience things that you don't have there outside of Sri Lanka. So I am biased about it. So So my whole presentation is based on it. So I will share the presentation and start it. Wait a minute. I think I shared the wrong one. Yes, this one. I have the QR code for my LinkedIn. If you have any questions afterwards, you can scan my QR code and go to my LinkedIn and DM me. Like I will answer any of your questions from there. So you have time to scan the QR. I will move on from now. I hope you got time to scan it. So I started like this. When I thought about field familiarization, the first thing I did is, since I use ChatGPT for everything, I uploaded your handbooks, computer science, ENTC, material science, and chemical engineering, and I asked this specific question. If one has the liberty to choose to go into any of these departments, what is the best choice? Think of me as a person just entered the college. Regarding AI job replacement, salaries paid in the USA, Australia, and Europe. I did not consider Sri Lanka because Sri Lanka is such a tiny country and there's zero to like opportunities for chemical engineering, and as well as other, I mean there are opportunities, but the higher potential is outside. So I thought that maybe you guys also want to migrate after just after the degree. So this is based on this. Okay, that's why I did not include Sri Lanka in this question, and this is what it gave. So chemical and process engineering does not merely produce calculations or reports. So it deals with physical production systems. Like the previous presenter, like he said, it's all about scaling up. So to scale up, you need a chemical and process engineer in any of the facilities. These are listed here: process design, plant operation, process optimization, core subjects of engineering such as thermodynamics, reaction kinetics, heat and mass transfer. All of these are taught in our department at an excellent level. I can attest for that. This is the answer it gave, ChatGPT gave, so I don't have to say anything about it. This is just ChatGPT, what ChatGPT gave me, because that's all I use these days for everything, all the decisions I make. And this I also gathered from internet and some research. This is from 2024. These numbers might change, and because of AI job replacement, highest paying college degrees in the United States. This was published in New York Fed, and you can see it's always number one, chemical engineering. Median wage mid-career is starting at 135K. That's about 8 crores or like 80 million US dollars. I suppose closer to 6 or 8, including all the, this is not with the taxes. So that will be your per year salary. This is the median wage, mid-career level salaries. So that means what you get after about 5 or 6 years of experience. And these are the fields that you can go in if you come to the United States: chemical and process engineering, biomedical and biochemical engineering, environmental, material science. All of these are possible with what you have right now, what you are going to learn from Department of Chemical and Process Engineering. So even this computer engineering, some might ask, what am I going to do with the computer engineering and data science engineering, like how it correlates. I will explain that later on. So I just wanted to show you these salaries that you can get. This is your earning potential. So I don't see why somebody would stay there like in Sri Lanka without migrating and earning this potential, because this is your potential, as you can see. And then if you that was US numbers, this is Australia and Europe numbers. As you can see, it all gave chemical and materials engineering and chemical and process engineering at top. And also you have to think about this: since you are entering the university right now, you will be graduating at about like, I think 2032 or 33, something like that. So US Bureau of Labor and Statistics projects computer programming employment to decline by 6% because of AI job replacement. This is something that you have to consider. If you are going to be replaced by AI in the next coming 4 to 5 years, your whole degree becomes obsolete. You will not be like, your skill sets, you need to have skills that are transferable skills that should be that should be taught in the university that you can use to, get a job anywhere. That even if you get replaced, you need to have transferable skills. And those transferable skills include core engineering modules such as thermodynamics, chemical kinetics, uh, and all the other like distillation and unit processes. So all of these is taught in chemical and process engineering. So some people ask what I'm going to do after the PhD. Why do you migrate? Why do you do higher studies? So from what I have gathered from coming to United States, I figured out that most of people are doing their masters now. So masters is becoming a bachelor's. So you have to think about pursuing your higher studies, even if you want to excel in the industry. So if you start a PhD program, example in United States, you can master out first. Like you don't have to do a PhD, you can degrade it, downgrade it into a master's degree. And then you can go to the industry from there. Or else you can complete the PhD and then you can choose the academic path and the industry path. Academic path, you can be a professor, or industry path, you can be anything you want, which I showed in the previous slides. So what I am planning to do right now is go to the industry. I'm not interested in becoming a professor or in pursuing a career in the academic area. And this is the cost breakdown. If you were to become a PhD student just after your bachelor's, so I graduated in 2023 December, I think 21st, 25th, on December 25th, just after 2 days, I came to United States to start my bachelor's, start my PhD. I'm sorry. After my bachelor's, I started my PhD after 2 days. So this is what I get paid. This is excluding what they pay for what the school pay for my degree. So degree is totally free for us. So take home pay, like this is like the take home pay that you can, this is bi-weekly salary, so it's like 2,200 per month, and with food and rent and utilities, that is 900. Depending on your lifestyle, you can save up to 1,100 US dollars per month. This is just a student salary, okay? This is not the salary that you get from the industry. So, and also the plus point of coming a PhD student into the United States is that you can do internships in your summer break, which in even the interns earn about 7,000 USD per month. So just for your information, I'm putting out here. And what are the perks of the PhD? If you want to do academics, these are you get additional scholarships. I get additional scholarships all the time. On top of that, what I get paid in the previous slide, I get additional scholarships. I get like, you can get free food and stuff like that from food pantries. You can get conferences to travel to. And when you have the US visa, traveling is like very easy for you with a Sri Lankan passport. And this is just personal perks I have got so far. From 2023 December, I have traveled to 4 countries: UK, Canada, Australia, Singapore. Most of these, I did not pay anything out of my pocket. All of these are conferences or something like that that the university paid for. So these are the perks that you get. And in your 20s, until you become 30, I don't recommend just being like, just, like in the box, like just being in Sri Lanka. You need to experience other countries, you need to experience other cultures, you need to experience other workplaces. So this is a really good opportunity for you. If you start doing your PhD or your masters, you get these perks that are like really good. And also, I'm not joking, you can go to my Instagram here and then you can see like where I have traveled. All of these are like, out of 50 states, I got to go to 15 states. All of these are just like conferences that I have to go and present my research. So everything is paid for. And so one last thing I wanted to tell you before I open it for like questions. I said that what I'm going to do with computer science engineering, right? So right now I'm in Texas A&M University, as you can see. I'm doing my research. 70% it is simulation based, it is computer based research. So I'm using supercomputers to run my simulations and get all of those results and then test it on the wet lab. So like, you don't have to be a computer science engineer to use supercomputers. You just have to use it. Like what I do is drug discovery and drug delivery. Like I am like making new drugs for different diseases and stuff like that. And But in my bachelor's degree at University of Moratuwa, I had a minor in environmental science engineering and also a minor in entrepreneurship. But right now I'm focusing on drug development. So that just I wanted to show you that it's not what you learned. Basically, it's what the transferable skills that you learned. The basic core of engineering, what you learned, is essential for this. So right now, I'm just running my simulations on these supercomputers. Texas A&M just my university just introduced the fastest supercomputer in the United States as well. I get to use that. I get to use it for my researchers. All of the things that I run. See, I'm always I'm like 20% of the time I have to code and I have to use these softwares and run it. So it's not chemical engineering is not using a beaker and a test tube. That is the one thing that I wanted to share with you guys because that's one thing I did not learn before coming to the University of Moratuwa. When I came to University of Moratuwa, I thought chemical engineering is like just chemistry. That is not it. It's one of the most important things that you learn is that what you learn as a core subject. And even mechanical engineering, I would say, and material science engineering, I highly prefer those things because you have the potential to go to so many other fields, just not be in just one field. um, so I will just keep you guys from showing this. Like these are the all the fields that you can go into, and you can ask these questions from me. But before you decide to whether to stay in Sri Lanka or to migrate, I'm just saying based on my experience. So I came just after graduation, right? Just 2 days. But my friends who stayed back and who worked at Paracom, which is a really good company for ENTZ, and also WSO2 and Cisco Labs, all of them, they are now looking for PhDs to come to United States now after about 2.5 years. So they have decided that they don't want to stay there. So I'm just saying, as the newest batch for you, just don't think about the opportunities you get in Sri Lanka because I'm pretty damn sure that most of you guys will migrate. So if you were to migrate, so when I came to United States, the some people say that okay, to do a PhD you need to have money. Your parents needs to have money. You don't have to have money at all. You just need the money for the plane ticket that you are getting from Sri Lanka to United States. Everything is covered for. Everything you get full scholarships. You don't have to worry about anything. You don't have to burden your parents. You can send money to your parents after coming doing your PhD. So PhD is the starting point. Masters is the starting point. And if you want to go to industry, like he said, it's really hard to get an industrial job in United States, even though you have experiences in Sri Lanka in the industry, because they don't care about the industrial experience in Sri Lanka. They want industry experience in United States. To get that, you can start doing internships and stuff like that for your summer internships after when you come for a PhD or a master. I have just one friend whose name is Vasuki, who did earth resource engineering and got a job because she worked in Germany, and she got a job in United States in Ohio as a process engineer for a vanadium plant, and she's earning uh, closer to 200K. That's 200K. That means 200,000 USD dollars per year, and that's just her starting salary. And she did not even do chemical and process engineering. She did earth resource engineering, and then she excelled from there to become a plant engineer in United States. So sometimes you might get lucky finding jobs, but it's really hard. So the first step is to do a master's or a PhD. So to do a master's or a PhD, as a person who's smart enough to come to University of Moratuwa, you should be able to figure out which field you should go to so that you can get the most number of advantages, most number of opportunities to go for masters and PhD. Like I said, that's why I did this question in the beginning from chat GPT. This is what it gave. I'm not biased, so just wanted to show you that. And all of these, just take a picture or keep a screenshot, do your own research by yourself to see which field you select, because this is going to be the most important decision that you make at your age right now. um So if you have any questions, you can ask me, or I gave you my QR code, and on LinkedIn, you can search, like I said, if you have scanned it, you can search that. If you have any questions, you can ask me. I think we have about 7 minutes. Yes, I got a scholarship for PhD. You need to have, I mean, aim for a first class because you are in your first semester. Aim for a first class. But my friend who's in Oklahoma State University, who's my research partner, she had a second upper, but she got in just like me, just after one semester. She got in here as well. How long does it take to complete a PhD? Typical time is 4 years, but in United States, it's 4 years, 4.5 to 5 years, depending on how fast you do it. But if you go to Australia or some sort, you can finish it in 3 years. Somebody has asked about the anti-immigration policies of USA. You don't have to be worried about because you are just starting. In 4 years, this government will be gone, and you don't have to worry about that. Even so, nobody who got scholarships did not did not get rejected for their visas. If you have a scholarship letter, offer letter in your hand, you don't have to worry about visas and stuff like that. You will get accepted for US visa. Petroleum engineering opportunity, yes. Petroleum engineering, I live in Texas in the United States. Here, the petroleum engineering is one of the most paid engineering fields in United States. I did my internship at refinery in Sri Lanka, Sipetco refinery, which is in Sapukaskanda. I did my internship there, and that has helped me a lot. When I go to internship interviews here in the United States, they ask what are my previous experiences. I always say that I worked in a refinery. That is like a big deal here, because refineries is where the utmost engineering like stuff happens. Thermodynamics or mechanical engineering, everything happens in a refinery. So they value that so much that you worked in a refinery, place where actual engineering takes place. So they actually value it. um so you obviously you can go get a job for petroleum engineering in Middle East as well, but I don't have any experience with regard, and so I'm not going to talk about it. So okay, I will show you the QR code. How many students get fully funded PhDs out of the whole batch? From our batch, from 2018 batch, there are 4 students from Chemical and Process Engineering department currently in the USA right now. They all fully funded PhDs, and 42 students from all the departments from our batch is currently in United States pursuing their PhDs. It does not matter how many students, because United States has about, I think, 6,000 or 7,000 research universities. You can apply to any of those and get in here. So it does not matter how many people get first classes or second uppers, even second lower. One of my friends who's in Michigan State, I think she is in second lower, and she still got a PhD opportunity here. What are the requirements to get a scholarship? Requirement is, like I said, you need to have a good GPA to get outstanding recognition from it. But most importantly, your research should be one really good research. You need to have a really good research in your bachelor's. I already had a paper published with my research partner, like I said, before my final semester. So before my final semester, I saw Ruani is my friend, and she and I published a paper before my final semester. So you need to have at least one publication in your name, at least a conference publication, or a journal publication to get a PhD. Yeah, of course. Somebody said that you need to like what I shared earlier. What are the AI job replacement that you have to consider? Because right now I know that few of my friends, my batchmates, I can tell you the names of the company too, but I don't know whether it's suitable. But they are getting salary cuts. because of this AI whole thing. Because now United States, countries like United States, Australia, and Europe, they outsourced stuff like that from Sri Lanka, but they are not doing so because of this AI replacement. You have to consider this because you are going into the industry in about 4 years. So definitely check about the AI job replacement, whether your job is replaced by AI or not. You don't have to finish your final year to get a PhD. You can apply in your 7th semester, which is the when you get into the final with your current transcript, you can apply for a PhD. Yes, you need to do IELTS. You need to do IELTS. Your It does not matter your GPA is under 3 after the first sem. It does not matter. You can get a first class because from second semester onwards, you will get, like, I think you get about 12 credits. I think I got 12 credits in my first semester. I still had a kind of a good GPA. In the first semester, I had about 3.62 in first semester, but even my friends had lower GPAs, but they got first classes and second uppers as they goes through, because this is just 1 out of 8. That's why I did a minor also in entrepreneurship to get my GPA up, because you get more credits with A pluses and A's. You can get your GPA to a good level. What age? Industrial chain? Yes, you can go to industrial training in abroad when you are doing your industrial training in third year. You can apply for abroad ones. I missed the chance, but few people told me that there were about 2 or 3 students from previous batches who went to internships in Dubai or something like that for petroleum engineering. So there are opportunities if you search enough. If you have connections, you can apply for it. What are the projects we can do during our 4 years? That depends. I did a project with industrial project. I did industrial project, a dyeing like a dyeing industry, like cloth dyeing, like textile dyeing, at a uh, Biagama facility, this industrial zone. I did a research there, and it's about dyeing, like basic processes like unit operations. You can do whatever the projects you can. I would suggest doing an final year research like that is more aligned to industry, like what I did. Two people asked me to share the QR code again. This is the QR. You can scan it. If you have any questions afterwards, you can reach out to me on LinkedIn and ask any questions you have. I think we don't have enough time. Yeah, it's 8:30. That's all the time I get. Um, you can ask more questions through LinkedIn. Thank you.
Thank you very much, Mr. Lasanlianage, for joining with us and sharing an eye-opening insight on chemical and process engineering. Moving on, our next session features with the Department of Civil Engineering. And I would like to invite our first speaker, Mr. Chanudedri Singha, who is currently working as a civil engineer at Master Haley's Engineering Consultants. Mr. Dirisingha, virtual floor is all yours.
Thank you, Sithani. Am I visible?
Yes.
Just
Yes, you are visible.
let me blur my background, otherwise it's okay. So let me share my screen. Is my presentation visible in the presentation mode?
Yes, it is visible as well.
Okay, thank you, Sithani. Yes, so good evening, everyone. I'm Chanudedri Singha, and I'm currently working as a civil engineering at Master Haley's Engineering Consultants. So today I'm here to introduce you to the Department of Civil Engineering and the course, and give you an idea of what pursuing a career in civil engineering could look like. I know that all of you now have an important decision to make because you have the opportunity to discuss, to choose between several engineering departments. Through this presentation, I hope to show you that the civil engineering is not simply about constructing buildings. It is a broad, modern, and highly influential profession that allows you to shape the world. Most importantly, I hope that this by the end of this session, at least a few of you will feel inspired to consider civil engineering as the pathway of future. So moving on to the next slide. Yes, so before we discuss civil engineering in detail, I want you to first look at how Colombo has changed over time. So let's look at the video. I hope it'll be, yeah, it's yes. I think, oh yeah, okay. So what we just saw was, I think the audios did not work in that. I would like to apologize for that. So what we just saw was the transformation of Colombo from what it was in the 1970s to the city we see today. So I would like to say the change is especially visible around the Gold Face area. What was once a relatively open coastline has now become an urban and more of an urban area. So behind every tower, road, drainage system, foundation, and development project, there were civil engineers who planned, analyzed, designed, and managed and constructed it. So civil engineers take ideas that initially exist only on concept, only on paper, and turn them into real structures that can serve thousands, millions of people. So that is the one of the most rewarding aspects of civil engineering that I see. You can look around at a city and see the physical results of your work. So let's move on to the next slide. Mm, yes. So I would like to speak about the civil engineering industry. In this section, I will briefly explain what I know about the industry and introduce some of the different career paths that become available when you choose civil engineering. So civil engineering, as I said earlier, is a broad profession. You're not restricted to one type of job, one workplace, or even a country. Depending on your interest, you may work in a variety of areas. So first of all, why civil engineering? So this slide shows four well-known developments: the Victoria Dam, a major highway interchange, the Lotus Tower, and Cinnamon Life. Although these projects are very different from one another, they have one important thing in common. Each of them required significant civil engineering knowledge. A dam must safely retain and control an enormous volume of water. A highway interchange must allow thousands of vehicles to travel safely and efficiently. A tower must resist gravity, wind, and other forces. A large development such as cinema life requires structural, geotechnical, transportation, water, and construction expertise. This project begins with just theories, calculations, models, and engineering principles. At university, at the Department of Civil Engineering, you learn the scientific and technical knowledge behind them. In the industry is where you receive the opportunity to apply that knowledge and transform the concept into something real. This is why civil engineering is often described as the backbone of national development. Every city needs roads, bridges, buildings, ports, drainage networks, and water supply systems. Sri Lanka also requires civil engineers to address urban development, transportation, housing, climate resilience, flood management, and infrastructure reconstruction. Therefore, civil engineering is not only about constructing structures, I would say. It's about building the systems that allow society to function. So moving on to the next slide. Civil engineering is not one career. So this is one thing that I would like to emphasize on, because many people think civil engineering as just constructing. You have to stay on site, and in Sinhala you have to katta kannoni. But I would like to emphasize that it's not the same. I mean, there's that aspect as well. So let's dive in. So first, there's a construction sector. The construction sector includes contractors such as Sankan Construction, Access Engineering, ICC, and Marg Engineering. I'm sure you have heard of it. Contractors are responsible for physically carrying out the projects on site. Then there's a consultancy sector. So this consultancy sector includes organizations such as CECB, Master Helios Engineering Consultants, which I'm currently employed in, as well as Lanka Consultants. Consultants help transform an initial idea into technical feasible design. So let's say structural design or a plan, let's say. So this is what the contractors actually build. So then moving on to the government sector, civil engineers also play a major role in government organizations such as RDA, Irrigation Department, and Mahavali Authority. So these institutions are involved in developing and maintaining in the country's essential infrastructure. So why I put a separate sector for this is because in Sri Lanka especially, there's a lot of funding agencies such as ADB, JICA, World Bank, which heavily invest on projects like this. So in this photograph that is shown here as well, it's the MWSIP project. So it's a tunneling project that is funded by ADB, which is planned for a 24 kilometer tunnel, which is heavily funded. So there's international organizations which invest heavily in this. So these constructions are being built. It's looking at the social welfare of the people of Sri Lanka. Next is the research sector. So this research organizations and universities investigate engineering problems and develop improved materials, technologies, and risk reduction methods. For example, following floods and landslides from Cyclone Ditwa. So organizations such as NBRO study what occurred, identified vulnerable areas, and develop measures to reduce the impacts of similar events in the future. Therefore, research allows civil engineers not only to solve the current problems, but also to prepare society for the future challenges. Next, I would like to talk about the overseas opportunities coming into the civil engineering department. So civil engineering also, I would like to say, provides a significant international career opportunities. So based on the alumni information taken from, I think, yeah, it was last year, yes, 2025. So 54.5 of the civil engineers alumni are working overseas, while around 45.5 are working in Sri Lanka. So this doesn't mean that everyone must leave Sri Lanka. Instead, it's just there to show that civil engineering qualification can, in University of Moratuwa, can provide both local and international mobility. So if you want, you have the opportunity to travel as well. So the major countries, the major countries shown are Australia, Singapore, Saudi Arabia, United Kingdom, Japan, and United States. So civil engineering alumni are also working on a few other countries, which is mentioned on the left bottom. So why I mentioned the country specifically on the right hand side is because those are the majority of students traveling to for their industrial work. So next, I would like to talk about the overseas opportunities in Japan. So the companies such as Asinaro Aoki have approached the University of Moratuwa to recruit young civil engineering undergraduates. So representatives from the company conduct programs to introduce students to the organization, its projects, and the available training and the career opportunities out there in Japan. Selected students, I would like to say the fourth-year students, may begin with a period of training in Sri Lanka, during which they receive guidance, facilities, and also financial support. They may then continue their professional training and employment in Japan. So this is one example, but it shows that companies do not simply wait for graduates to find them. International organizations actively recognize the quality of civil engineering graduates from the University of Moratuwa. Therefore, choosing civil engineering can connect you to opportunities that extend far beyond Sri Lanka. Moving on to the next slide. Yes. So what I mean by civil engineering is becoming modern is that some people may still imagine civil engineering as a traditional profession involving concrete drawings and construction sites. However, modern civil engineering is increasingly digital, automated, and technologically driven. For example, building information modeling, computer-aided structural design, robotic construction, hydrological modeling, drone surveying, bathymetric surveying. So these are all examples of how modern civil engineering is becoming. Civil engineering is continuously evolving, and the department exposes the students to these modern tools and emerging technologies. Therefore, choosing civil engineering does not mean entering an outdated field. So by this, I would like to also say that the civil engineering department continuously researches on what is the construction industry out there, and they prep the students by updating their curriculum on whatever the new software that is being used. So they all implement it into the curriculum of the civil engineering curriculum in the university. Next, I would like to talk about why choose civil. So, I mean, why should you choose civil engineering? First, I would like to say civil engineering gives the opportunity to create practical and visible impact, which was one of my major requirements, because I would like to see the results of the work that I did. So you can see it becoming a building, road, bridge, drainage system, whatever infrastructure that you've been involved with. Second, you can choose the type of working environment that suits you. You may work indoors in a design or a consultancy office, outdoors at a construction site, in a laboratory, or in the field collecting and analyzing data. Third, the profession offers many areas of specialization. So that was mentioned earlier, I believe. You can also build your career in Sri Lanka or have the freedom to pursue opportunities overseas. Next, yes, most importantly, civil engineering allows you to build a career that directly and positively affects people's lives. The decisions made by civil engineers influence where people live, how they travel, how they receive clean water, how cities respond to floods, and how safely buildings and infrastructure perform. Therefore, I would like to say civil engineering is not about building structures alone. It's about building safer communities, stronger economies, as well as a better future. Yes. So next slide. Yes. So yes. Next, I would like to talk. Next, I would like to transfer. Yes, give the session to my friend Vinuka, and she will talk about how you can transition to the higher study section after your BSc in civil engineering.
Yeah. Thank you, Samuel. Am I audible?
Yes, you're audible, Vinuka.
Okay. Thank you. So let me first introduce you all, myself to you all. I'm Vinuka Ratnayaka, and I'm currently pursuing my MSc here at the Department of Civil Engineering, and I'm from the 21st batch. So up to this point, we have looked at the wide range of industry opportunities and the career pathways that is available through civil engineering itself. So, however, civil engineering does not only prepare you to enter the industry, it also provides you strong pathways into research and higher studies, both in Sri Lanka and internationally as well. So let me start with the building and structural engineering division within the department itself. So the research within the department of the building and structural engineering division includes structural design, computational mechanics, concrete technology, deployable structures, facade engineering, form resistant structures, and many more than that. So this is beyond the conventional design of beams, columns, and buildings. So for an example, if we take computational mechanics, it represents numerical simulations where we use finite element modeling that allows engineers to visualize stresses and deformations, cracking, and other failure patterns prior or before the structure is constructed. And also, one very good example is deployable structures. So deployable structures are structures that can fold, expand, or transform. These may be inspired by origami and other mechanical systems, which can be applied to temporary shelters such as tents and even for space applications as well. And also facade engineering and form resistant structures. And these form resistant structures are structures such as arches, shells, domes, and cable systems, which use their geometry to transfer the loads efficiently. So these kind of research are happening in the department as of now as well, which are quite interesting and also trending fields within the domain of structural engineering. And beyond that, we have many more other aspects of building and structural engineering aspects, such as research on steel structures and retrofitting of structures and structural health monitoring, because as of now, given all the structures that we see as of now has been existing for quite for a couple of decades now, we need, this area is becoming much more popular because we need retrofitting of structures, which means an existing building or a structure, rather than completely demolishing it, we can do several things to strengthen the structure and use it for another couple of years. So, and also structural dynamics. So research related to this includes blast modeling and also vibration analysis, which are like quite demanding as well as very interesting fields. And also timber in structures, which is more towards the sustainable aspect of research activities that is happening within the department itself. So these are very interesting and very popular aspects of structural engineering, which is happening within the Department of Civil Engineering at University of Moratuwa, and also which has a very high demand globally as well. And then let us move on to the other divisions, such as geotechnical engineering division, where we mainly examine the ground on which every civil engineering infrastructure is standing on. So the research areas will include landslide analysis, slope stabilities, and also which involves analytical and numerical methods to analyze these behaviors of the soil structure, and also the state of the art facilities that is there within the department as well. And also more than beyond structural engineering and geotechnical engineering, we have other divisions within the Department of Civil Engineering. So, I would like to mention the next slide. Yes, the hydraulic and water resources engineering. So within the department itself, we have many more research activities which are targeting this hydraulic and water resources engineering, also given after this cyclone Ditwa incident as well. So groundwater modeling, drought modeling, coastal engineering, those aspects. So students who are interested in these aspects of irrigation modeling, floods, rivers, coastal systems, this is the place. And also, more importantly, the department is the home to UNESCO Mananjit Singh Center for South Asia Water Management, where even currently a number of postgraduate students are currently studying it. And also, moving on to the next field, which is the transportation engineering field, which also falls under civil engineering. So civil engineering is more than concrete technology, it's beyond that. And also, for an example, we have transportation engineering. So here, this research that is happening within the department itself on transportation is going well beyond designing roads. It includes multimodal transportation planning and sustainable mobility, traffic engineering, which involves intelligent transportation systems and also highway planning, asset management, and also other highway material research as well. So the field is well suited not only for students who are interested in infrastructure, but also to those who are interested in data analysis and also AI technology as well. And also structural engineering and management division, which brings together the engineering and sustainability, materials technology and project delivery part as well. Can we move to the next slide, please? Yeah. So here, going beyond the conventional research activities, you can see what's happening in the department as of now as well. We have the probing laboratory, where one of the very good example we have added here is the use of post-industrial textile waste in thermal simulating cementitious sealing sheets, which is a research which are research activities that has been conducted at the department. And also beyond that, using energy efficiency, thermal comfort in buildings, and also drone mapping and also digital heritage construction, which demonstrates civil engineering research can contribute to this circular economy, improve building performance, and beyond that, preserve the culturally important structures as well. So on that note, that we have introduced you all to the many engineering research activities that is happening at the Department of Civil Engineering, and which is beyond this happening at a very higher level beyond Sri Lanka globally as well. Let us introduce you all to a key figure who has joined us today, Engineer Sachin Silva. We are pleased to welcome Engineer Sachin Silva, a first-class in civil engineering graduate from the 18th batch and a former lecturer at the University of Muratua, and he's currently a PhD candidate at the RMIT University in Australia, specializing in geotechnical engineering. I would now like to invite Engineer Sachin Silva to join us in the conversation.
Yeah, thank you, Vinuka. So basically, I will give you a guidance regarding the highway pathways in cities, like very familiar thing to me. So as my friend Razan mentioned about the high studies regarding chemical opportunity, as you have observed those charts, even though it is not top on the list of the salary scales in foreign countries for occupation work, but still it has a decent amount of salary that you have seen from his data, which is shown from his statistics. And as well as civil engineering is a grown industry in every other part in the world. So there's a cycle. That means sometimes there will be a high number of opportunities of jobs abroad, and sometimes there's a downfall, which happened in Sri Lanka after COVID. But anyway, construction need to happen in every country in the world. So it is a continuous process, the development of buildings and other infrastructure. So, civil and in the long term, civil engineering is a great place to work and build a career for your future. So, when moving on to my journey at University of Muratua, I was 125th in the batch, and I had the privilege to join whatever the department I want, but with the enthusiasm to have in construction projects and work as a team player on building things which is very tangible and very visible to real world when you are walking in day-to-day life. I thought to choose civil engineering because that was the one which I got the passion to work. So with that enthusiasm, I worked during the 4-year graduation undergraduate study. So during that period, it was a very good time, and I had the privilege to work on extracurricular activities like joining clubs like Rotrack, Isaac, and holding like high-level positions there, as well as civil engineering organizations, and do my work and graduate as a first-class engineer. After that, during my undergraduate studies, actually, I opened my opportunities for both industry as well as higher studies. As I had already secured my first class, so my thought was to go for a higher study opportunity, and I searched for in different countries, and Australia was the one which I chose because it has the highest amount of occupation and opportunities for civil engineers. So I landed a PhD at RMIT and currently working on that. So even though civil engineering is like building structures and other designing work, with the advancement of technology, AI has come into the civil engineering, but it does not affect any jobs. but it will be creating jobs as well as making things much easier for construction. So in my PhD research also, what I am doing is I am developing advanced deep learning models for soil classification and property prediction using images and other relevant data for Australian soil, because it is one of the main things happening in Australia, because due to huge immigration here, there's a housing crisis going on. So my project is to uh, give some support for making the site classification work very fast. So it will support to improve the efficiency of housing construction work. So that kind of thing is there. And as Chandra mentioned, many of the students past alumni of civil engineering department are abroad. When considering the amount of PhDs held by last few batches, in our batch, we had 124 members. Out of that 24 members, 25 landed PhDs on different countries of the world, including Australia, USA, Canada, UK, likewise. And considering our junior batch, the 90th batch, already they have secured 20 plus PhDs. That means getting a first class in civil engineering department, definitely secure a PhD. And if you have masters, you have the ability to do a master. If you have second upper, you have the ability to do a master's and then go for a PhD. That the opportunity has also several students have secured that opportunity as also. They got second uppers, they did the masters, and they secured their PhDs. If you are first class, it's very easy. You can directly go for a PhD in many countries. Australia is a very easy country to secure a PhD if you have first class in civil engineering. So with that high numbers, and as well as if you are considering the total number of students who are working or studying abroad, in our batch, out of 124 students, we have 88 students working or studying in overseas at the moment. That means I told the exact number because we have a sort of active ticker in our WhatsApp group. When someone leaves, it gets updated. So that doesn't mean you have to leave Sri Lanka if you do civil engineering. There are plenty of job opportunities at the moment in Sri Lanka. The industry is growing, and everyone of the, I think, recently passed batch also got job opportunities. So with that, it would be very great opportunity for you to join the civil engineering department and pursue your career and work hard to get a first class. It is not a very difficult task. I did many other extracurricular work also while I studying, but I still managed to secure PhD at a top university in the world. So and getting a first class is not much difficult. The lecture staff also very good and friendly, so you can pursue your undergraduate career at University of Maratua and go for a PhD opportunity in any other country. Don't worry. If you want to go to industry, still, if you have first class, you can do a PhD. And after that, you can join the industry, because I have the same idea. My main intention is to join the industry, but I'm still doing a PhD in AI, relevant to geotechnical engineering because it's relevant to soil classification. And after that, I will be moving on to the industry. My PhD project is also an industry collaborated one. So basically, I am doing soil testing work and modeling work with a partnership with a like very large scale company in Australia. So there are plenty of opportunities, and most of the students who got into civil engineering have gone to different countries because there's a higher salary scale. When we consider there are like 20 from our batch, there are around 20 people in Japan, around 15 in Saudi, and 10 around 8 or 10 in Dubai. So they have very good salaries, and they have gone for that directly just after graduating without any prior experience. And many came to Australia for PhD. Around 15 people are in Melbourne currently pursuing PhD in my batch. Overall, it's around 25 now, and like several other students, people are still looking for PhD after staying some time in the industry in Sri Lanka. That is also a possibility for you guys as well if you don't like directly to apply. But best thing to apply for a PhD on civil engineering is best to apply as soon as you graduate with a first class. If you are second upper holder, definitely do a master's. You can go for a PhD. There are plenty of opportunities available, research grants available in the department, so you can do a master's and secure a PhD. Only thing is, do a good undergraduate research and do a publication that will be sufficient with your first class to directly go to a PhD in a class university. So that's basically the statistics I want to tell you. There are plenty of students each year going for PhD from the civil engineering department. Many go for the industry in foreign countries around the world, and some are staying in Sri Lanka as well, according to their wish. So that's their choice. So thank you for that.
Yeah, thank you, Engineer Sachin. Yeah, I would like to add a little bit more to that. And once again, I thank Engineer Sachin for sharing the great advices and his perspectives on civil engineering. So, sharing with you all a little bit about the global higher study opportunities that has been secured by our 19th batch remarkable graduates from the department, where they have secured PhD opportunities all over the world in United Kingdom, USA, Canada, Australia, Singapore, and also a couple of MSc opportunities as well. And with that, I would like to end by also sharing with you all some of the emerging research opportunities that is there currently trending. So future research includes such areas include additive manufacturing, such as 3D concrete printing projects, and also multifunctional composites, smart and multifunctional composites, which can provide structural strength by also supporting sensing, heating, and also energy storage, as well as health monitoring purposes as well. And also civil engineering is also evolving, as explained by the previous speakers as well. It is increasingly connected with AI, robotics, advanced materials, sensing, digital twins, and also even currently within the department itself, we have several research activities that is going along with the AI technology, machine learning aspects integrated as well. So with that, we would like to conclude our presentation. I'm wishing you all the very best and good luck with your degree program. We invite you all to the Department of Civil Engineering, where you will be able to build a legacy beyond a lifetime. Yeah, thank you. Thank you for this opportunity. Thank you, Sitali.
Yes.
Thank you very much.
Sydney, I think we're running a bit late for questions, right? Is it fine if I answer one question?
Okay.
Is that okay?
Yes, go on.
Yes, so there's a question asking, can a civil engineer become, sorry, the question went away. Yes, can a civil engineer become a successful by starting a business instead of doing a regular job? I would say that's the option to go for, because as you know, starting a business, there's a you can have a big return. But I must say, the civil engineering industry, you must know the industry very well before starting a business, because there are a lot of there's a lot of areas that you can that you have to know before starting a business, such as so let me talk a bit about my company that I'm currently working in. So what we do is we take projects by clients, and we analyze if it's possible to do, and then only and then we submit a proposal, and only if it's approved, the project is actually constructed. So as I said earlier, civil engineering is very broad. The areas are very diverse. So there's actually a group of companies in Sri Lanka that actually check whether a project is actually feasible before being constructed. And so basically, let's say to start a company like that, you must know each and every division of civil engineering very well. So let's say for example, a multi-modal hub. Multimodal hub is when you have trains, buses, tuk all at one center, and then it's like a place where they can change between those hubs. So that's why it's called a multimodal hub. So for that, you must have know the transportation side, the environmental side to get permits and approvals, as well as the hydrology aspect. So to ensure that like all the drainages are not going to be an issue, and the geotechnical side, which is essential for every structure. So like that, you must know a broad idea of the full civil engineering industry. What I mean by saying that is not that you should know technical details of everything, rather just grabbing the basic concept. Because in my company, in the company that I'm in, we give consultancy to professors. Like if we don't know something, we consult them, and then we include them in our proposal to ensure that our proposal is technically sound. So that's just my company, the company that I'm currently in. But there's a lot of opportunities. You can start a contractors company. So it's an area to definitely look at, and definitely rewarding if you do it right. So what I'm trying to say is grasp the concepts. If you are interested, grasp the concepts very well in your undergraduate, and get into the industry, see what's out there, and you have to be smart and lucky to understand and meet connections, to have connections, and then I would recommend to start a company. So I think that answered the question, and I'm sorry I don't have any time to answer other questions. But if you have any questions, I would type down my email. You can ask any questions, and if there's any other questions to ask from the Sachinaya, who's a PhD graduate, and Vinuka, you can direct them here. I can direct it to them. Is that okay, Situli?
Yes, I think that's better since we are running a little bit tight on time.
Yeah, exactly.
And thank you very much, Mr. Chanudadiri Singha, Ms. Vinuka Ratnaik, and Mr. Sachin Silva for joining us and sharing a great presentation with us. And thank you for your valuable insights on civil engineering. And our next session features with computer science and engineering department. So our first speaker is Mr. Navidya Silva, who is currently in National University of Singapore as a PhD student pursuing a PhD in computer science engineering. Mr. Navidya, floor is all yours.
Thank you very much for inviting me and giving me this chance to speak. Can I confirm if I'm audible and you can hear me?
Yes, you're audible.
Okay, so let me share my screen. Is a slideshow visible?
Yes, it is visible as a.
Okay, thank you so much. So it's going to be a very short presentation, but I will try to motivate you. So I think a lot of I was listening actually onto most of the other presentations about the other fields, and especially the research and PhD direction. So there were a lot of interesting ideas, and I think very useful tips, which will also apply even in my case within the computer science field, about how can we try to apply for a PhD. So my focus for this session would be like, why would I suggest you to take up computer science and engineering, and what are the ways and motivations on why research in this field is valuable and important for you. Okay, so to introduce myself, my name is Navindu De Silva. So I graduated from the Computer Science and Engineering Department at the Faculty of Engineering at the University of Moratuwa in 2025. So very recently in the intake 2020. And now I'm currently pursuing a PhD in my first year at the National University of Singapore. And my research interests are particularly AI machine learning, and particularly I'm working now in LLM agent systems and memory. So like what I want to show you is that computer science is not like a single domain about computers itself. So most of the time at the very start, when computer science was first developing, at least, or maybe the way you might have thought computer science was about, is something more on the closer lines of software engineering, building applications, building computer programs that you can use, websites, programs, which you can use for different services to help us in different manner. And now maybe in the very recent few days, we get to hear things about something like AI, artificial intelligence, and machine learning concepts, which are being now very useful to do much more interesting applications, such as chatbots or ChatGPT or Claude, or like those type of applications, which I'm pretty sure most of you all have been using these days. And these days, with AI going about, you might feel like, is this all that is there in computer science? So I want to tell it's not that so. There are multiple different areas of what computer science can cover. Because we try to look at a computer system as a whole, and in the different aspects that need the computer system to help to successfully perform well and efficiently. So this can come even to protecting it, to make sure that it's secure. And that is what the area like cybersecurity will look at. And then we try to say about how we can manage the data, the information that is given to the computer system, and how it can process them. So those things, those are type of concepts that data science methods and database systems try to look into. Then we have computer vision, which will try to understand how does a computer can visualize and see this environment as well. So we can try to understand even from visual aspect, rather than just us explaining in words itself, whether how a computer can efficiently do that as well, even. And then we have robotics also. So we, as part of the computer science, we also do programming of robotics also. So it's not just limited to electronics as well, actually. And then we have distributed system, which is trying to understand how does a very large network of users can work in across a large space, especially when we are working in a very connected world with the internet. How can a lot of users across wide range of countries can be connected and ensure that that connection is stable and also consistently available for everyone. And that is also something along what computer networks will also look into. And then at the end, what computer systems also will try to look at is how computers will be used by humans. So there is what something like human-computer interaction is also considering very importantly, because we need to know how we can efficiently make computers usable by humans. And it's not just our laptops or desktops as well. It can also be our smartphones, the way we use the computer mouse, or how we use the keyboard, and even how we wear smart glasses, smart devices. And those things also come under this area. And even another area that is developing is also bioinformatics, which is also considering how we can encode information about our body and biology and into a computer system, so that we can also process information and try to identify various information about our body using machine algorithms as well. So as you can see, computer science is not just limited to working on a program and building it. It covers a very wide range of areas. So that is why research for computer science is such an important area. Because what we try to do in researching computer science systems is we try to advance computing by solving open and challenging problems. So we try to sometimes have to understand, can we try to easily visualize whether machines are able to understand complex problems easily? We try to improve existing technologies. I'm pretty sure if you ever have seen how ChatGPT had grown from a LLM that can try to just spit out text, random text. But now you can even have a very long and even almost a human-like conversation with an LLM like ChatGPT. And that is because researchers have been improving it over multiple years. And now that speed is also getting much faster than we ever anticipated. And like that, we try to create new algorithms, systems, and applications to make sure that they are able to run efficiently. And even more than that, we try to also research what are the limits of what computers can actually solve. And then we can try to understand how we can push those limits as well after that. So these are some of the examples that I can give, but there are a lot more of these. So what you can see here are a lot of different ways that it can help directly to the human user as well. So we try to find algorithms so we can find the fastest route in a map, or we try to improve processors and GPUs so we can run those very expensive computations that AI machines are taking these days, or we can try to find ways we can detect dangers that are coming from cybersecurity, and even AR systems that can help people with visually impaired so that they can navigate safely as well. And even some of these are some of the examples which you can see that are directly helping users and humans. But there are also areas in computer science which we might not see a direct connection and help to human users as well. So most of those things are coming in theoretical computing, and those things are also important because those parts only try to help build on to make systems that can actually help humans as well. So if you ask what does research mean for computer science and engineering, the aim is at the end to develop computing solutions that can make technology more capable, efficient, reliable, and beneficial for the society as a whole. So this is what I want to to sort of motivate you to understand what is the benefit of trying to research in computer science and what the wide ocean you have to search and research on a very large scale. So in what ways can you do research opportunities? So there are two common ways, and I think some of the earlier sessions also showed the two distinct areas. So in one way, you can do in the academic setting. So you can do as a master's or a PhD student, and even later on, you as a postdoctoral researcher or a lecturer or a professor after you get a PhD, you can also engage in research in these areas of computer science. And also, we can also, in an industrial setting, also work in research as a research scientist and research engineer, especially in large tech companies, as you are very familiar with the acronym called SANG, which is a set of companies which are the big tech companies in the US. They just Facebook, Apple, Alphabet or Google, and then Netflix and so on like that. There are some set of companies. So there are opportunities also to work in such large companies as well across the world once you do research in computer science as well. So if you're planning to do something on research in PhD as a student, there are a lot of universities that are undergraduates who have graduated from computer science and engineering department have gone to pursue now, and they are across the world. So currently I'm in Singapore, and then there's students who have gone to USA, Europe as well, and even Australia, and even also New Zealand as well. So there are limitless options. And more than that, because of the interest that especially domains like AI and also the related areas also have, it also has been much easier to find opportunities to do research, especially in computer science as well. So it is very easy because a lot of people are now really deeply interested in solving these computer science problems now. And as I said, you can also work in the industry. So there are a few areas here. So this is not an exhaustive list. So there are a lot more areas you can look into. And there are a lot more areas which we believe that future undergraduates from our department and our university would be able to go and work in as well. So Microsoft, Google, Amazon, and so on, Meta. So these type of companies are always actively looking for researchers because there are a lot of unsolved problems and a lot more solutions are still expected. Even if we still hear problems about that AI is taking over the work, or that there are a lot of unemployed workforce, still there are things that are required that we need the expert knowledge. So sometimes it comes from that aspect that we might need research to help understand how we can solve some of these problems as well. Some of these deep problems, complex problems in computer science. So I will not actually cover about how exactly you can apply for PhD, because I think a lot of that content is very similar to how my other fellow presenters had explained in the earlier sessions as well. So I'll focus on how does CSE the Department of Computer Science and Engineering help you to pursue research if you're interested in. So obviously, you have to have that personal interest within yourself to decide whether you want to go for research or PhD or academia. But if you are, there are many ways. So for instance, our lecturers and professors provide ample opportunities for you to help in their own research projects. And very recently, I have noticed also, it does not mean just your final year project or your academic semester projects. You also, if you're really interested, you get the chance to collaborate and see how you can work with other postgraduates, other researchers, scientists as well within your department as well. And that gives you the chance to sort of build up your academic profile over time. And not just, you would not just have a simple project under your FYP, you will have multiple projects and multiple collaborations under you as well. And if you have the interest, our department definitely will try to motivate you to try to do research publications. So you will get the chance even to publish at very high competitive ranked research conferences and journals, which are even very difficult for even my current PhD colleagues even to publish papers as well. So we can see you basically get the chance to even compete with those PhD researchers and postdoctoral researchers who are even still trying to publish for these conferences. And our department will definitely provide you the assistance, the mentoring, and how to write papers even to get into these conferences as well, provided you have that interest. And you get the chance to collaborate with foreign researchers and universities for projects. And I do not mean just Sri Lankans who have gone to other universities abroad and you get to collaborate with them. I mean that you can even collaborate with foreign collaborators as well, foreigners. So personally, in my experience, I got the chance to collaborate with 2 senior professors from the University of Otago for my final year project team. And it was a really valuable chance for me. So I got the chance to basically to interact with people outside my university and got the chance to learn a lot more new things and learn much what is more beyond what is your globe, the bubble of, if you are in University of Morata, you get to explore beyond that bubble. And it gives you a really good opportunity, especially if you're hoping to go for PhD or research later. You get the chance even to get recommendations from them as well, if you can get a good research done. And also, actually, CSE also organizes and attends research conferences. So actually, I think the last 2 years, the Department of Computer Science and Engineering has been organizing a research conference as well, known as ATSCI, for Applied Data Science and AI conference. So in addition to even attending a research conference in your university, you might even get the chance to organize research conferences as well. So you can get to look at research from a different angle and aspect as well. And personally, when I was the co-chair for the last year's ATSCI symposium, it was a really valuable chance for me to see the organization and how researchers try to come together as well. So I think when you see here, you can see that CSE can give you a unique way of how to support your research journey if you're interested to go towards academia or into a research career as well. So these are some examples so that I have taken from. So I'm not just saying it out of just saying things out of thin air. So we have some student projects that go to win awards as well. And also, as I said, you can see the organization of the symposium at Sky 2026 this year. And some of our projects, undergraduate projects, win awards. And one of our professors, Professor Dulin Madam, was also listed as one of the world's top 2% of the scientists under Elsevier publications. And also, I'm not sure if you were familiar, had heard recently, last year, I believe, that one of our undergraduate projects, actually, it was a final year research project. Singlama was the first large language model for Sinhala, actually. And it was developed by 3 undergraduate students at the University of Morata for their final year project. And it was the first LLM model developed for Sinhala with a large corpus of single language. So it gives, you can see that even your undergraduate projects can give you the chance to give a large, valuable contribution, even to the country, to Sri Lanka, to make valuable research contributions as well. And you can get the chance, as I said, you can get to contribute using your technical expertise at CSU. So these are some of the ideas that I want to present to you on what you can expect if you decide to choose CSA as your field selection. And you can, if you're interested in research, there are, I believe you can find ample opportunities. You will have in mentoring opportunities with your lecturers and other senior alumni members as well. If you want to get assistance on how to apply, on how to prepare for your research journey or career as well. So I believe I have been able to provide you some valuable information. And if you have any questions, I'm happy to take, but I'm not sure whether there's enough time. So I will let the organizing committee and the host to tell me about that. But if you have any questions, you are free to email me or reach out through LinkedIn as well. And I hope wish you all the best for your field selection. And thank you for listening to this presentation.
Thank you so much, Mr. Navidu. And our next speaker is also from Department of Computer Science and Engineering. I would like to invite Mr. Santhil Ranasinghe, Senior Software Engineer at Below AI.
Thank you. Can I verify that I'm audible? Sorry, one moment. How about now?
So we still can't hear you.
Sorry, how about now?
Hear you, Sandil.
Yeah.
I can hear you, but I cannot see your screen.
Okay. Sorry, I think something was wrong with the mic. Yeah, screen is visible.
Now it's fine, sir.
All right, thank you. So I'll keep this very short because we've taken a lot of time and it's a little late already. So Navidu talked a lot about the academic side of things and what you can do if you're interested in a PhD and whatnot. I myself don't like academia that much, so I'll just talk about the industry side of things for computer science. So I'll talk about like what you would actually do in a software jobs, what computer science and engineering gives to you that you can't learn later, and the pathways that you have available to you if you do computer science and engineering. So one thing to keep in mind is that software is the only engineering discipline where, as a fresh graduate, you can ship something that reaches 1 million people in the same year. You don't need a factory, you don't need advanced mechanical equipment, you don't need to spend $1 million on procuring construction contracts and capital to make a building or a bridge or whatever it is. A laptop and an internet connection and whatever is in your head will let you make software engineering products. So that's definitely something to consider. But so here is a few other things about the field as it is. So one thing that is very unique to software engineering is that demand is not local. So competition and the market for computer science is everywhere, all around the world. So you can see this reflected. You have so many graduates from our department working in countries all around, working in companies all around the world. And not only do they go abroad and work, but they work for other companies remotely. They coordinate with global teams all around the world while they are still here in Sri Lanka. There are Sri Lankan companies that have local clients as well as foreign clients. So that means you can build, work for, and earn from foreign markets without leaving Sri Lanka, and you have a lot more accessibility. I'm not saying this is not there in other fields, but typically in a lot of other fields, if you want to work for a foreign company or a foreign market, you have to go abroad and you have to be there. That's not something that's there in computer science and engineering. Second is that computer science and engineering has very fast feedback loops. You can get an idea, you can make a prototype, you can pitch it to investors in just a matter of weeks or months, and you can iterate on that and deliver your product, grow your consumer base in a fraction of the time it takes to see something materialize in another field. So that's again some unique aspect of the field of computer science. And this is particularly for anyone who has any entrepreneurial ideas. You don't need that much. You relatively need much less capital, much less money to start a product or a company compared to like a hardware venture or something like, I don't know, construction, making machines, whatever it is. So, and finally, in today's world, there is a computer everywhere. There is the internet everywhere. You can't be a doctor without connecting to the healthcare systems, using your internet, using the hospital systems, using tools to help you diagnose patients, keep track of medical history. You can't be a financial analyst without like 100 other financial analysis tools that are all dependent on computer science. So no matter what field you look at, computer science is going to be a requirement in today's world for that field. So even if you have like a partial interest in some other field, be it logistics, agriculture, I don't know, finance, fintech, whatever, but you also like the idea of building software, building systems, building computer systems yourself, then you can come to computer science and engineering, learn the fundamentals, and then you can go to whatever domain you like along with it. There are so many people who are domain experts in different places like finance, medicine, logistics, whatever, who use computer science to build those systems with their domain expertise. So they get to both work in that domain and use computer science. So those are 4 things that are fairly, I would say, unique to computer science. So again, sometimes there is a misconception that you just sit and write code every day and that is all there is to it. It's a lot more complex and a lot more diverse than just writing code. So most of the work in computer science is finding a problem, understanding that problem, and figuring out how to solve that problem. What are the best ways? What are the pros and the cons in solving the problem in different ways? Communicating with teams, designing systems, designing workflows. For example, I was once working on a small implementation of a system at one of these rubber and what you call shoes making factories. So we actually had to first go around the factory, understand what each person does, understand what happens in the machines, and we had to do all of that before we were able to digitalize what was going on in the system there. So you have to understand and you have to convert requirements and design and engineer systems. So that's what you actually mainly do, and coding is a very small part of it. So I think I have a slide for it. Yeah, I will get to that later. But with today, coding is even with today's like advancements in things like artificial intelligence, coding is becoming an even smaller part of the job. So yeah, I will get that when I get to that slide. But if you look at the different facets of computer science and engineering, it's not just like one simple face of a cube, or I don't know what solid object has 8 faces, but you have different areas no matter what domain you work in computer science engineering, and you find engineers in all those different areas, and all of those different areas are very different. They have very different things you do. Some don't even involve writing traditional code, and yes, for some fields are like the polar opposite of other fields, and even if you hate one field, you might like another field. So some are product engineering, that's like your typical products, web applications, the market application, or a game, or a software for end users. Then you have infrastructure management, which is about the cloud, distributed systems, making sure that pipelines are working, deployments are there, storage is there, everything is connected, cloud is running functions, whatever it is that those people do. Then you have machine learning and AI engineering, which is all the hype these days. You have everything from image generation to analyzing images to large language models and agentic AI and all that. Then you have data engineering, which is about working with massive amounts of data as in billions and billions of records of data you cannot possibly comprehend as a human being without computers. And you have to engineer how that data is going to be collected, where it's stored, how to analyze it, how to analyze a large amount of data without taking several days to run a single query, stuff like that. And then another hot topic today is cybersecurity. So cybersecurity itself is a big field, and any large company will want to focus on its own security systems, and there's like a lot of things in that field. And yeah, and then you have embedded systems, which is working with like firmware, hardware, sensors, whatnot. And if you don't like too much coding but still want to be involved, there is product management, engineering management, and stuff like that, business analysts, things you can go pivot off of computer science and engineering. And of course, you can go into like consulting or founding a company focusing on a specific product, or just consulting for people to solve little problems they have, or some specific field of expertise. And so those are the different things that computer science engineers do. And where they do it in all sorts of fields. So you find it in web applications, you find e-commerce, education, fintech, games, health, telecommunication, insurance. There are defense companies even, and artificial intelligence. So there are different domains that you might like and you might not like. There are different areas to work with that you might like and not like. So one of my biggest advice to you is, if you want to know if CSE is the place to come to, maybe you should take a look at what each of these different areas entail, and whether any of these domains and the kind of software, the kind of computer science engineering, the development in these different domains, whether those interest you or whether they don't interest you. Because, for example, someone who is interested in cybersecurity might absolutely hate something like typical product engineering or embedded systems. But that doesn't mean they shouldn't come to CSE, because they can go into cybersecurity if that's something they really like. So there's so many different fields to explore in this. So my best advice to you, to see if you want to come to computer science and engineering, is to look at these fields and see what interests you. So if you go into the industry, so I mean, Navid talked about going into academia and getting a PhD and masters and all that stuff. So I'm not going to talk about that. So if you're going into industry, you can typically have a career that looks like you start with a junior engineer, and then you move into a senior engineer position where you own something, you start designing, and eventually you work your way up to like a tech lead or architecture sort of engineer within like a 10-year span. And one of the best things about computer science is, while you can learn a lot of these things online, like syntax, so basically if you have the foundations, the fundamentals that you learn at computer science and engineering, you can learn any related technology that comes up in the field just by yourself. If there's a new, so today if you were working with React, and tomorrow there's a brand new shiny framework with some funky name, you can just learn that online, as long as you know your computer science fundamentals. If you know how machine learning and AI works, you can keep up to date with all the new changes with large language models and generative AI and agentic AI and all that. So basically, computer science and engineering, the department gives you the fundamentals and the foundations you need in those terms. And after that, you can learn a lot of things, pivot into a lot of things by yourself. So if you like, that sort of a thing, then computer science is again a very good place for you. And so I think I'll cover this also, because this is a hot topic these days. And a lot of people keep asking me, what is going to happen now that artificial intelligence is there? So with artificial intelligence, what has mostly changed is, you have switched from just being a field dominated by a lot more coders than engineers, into a field which is dominated into the engineering aspect of computer science. So now what AI functions is as like a very good assistant, or your personal assistant. You can shout at, tell him to write this function. So basically, if you engineer a system, you don't even need to be very good with your Python syntax. You can tell the AI to follow the specifications that you designed and implement those things. So that is how AI has sort of changed the industry. So ultimately, the computer science engineering aspect is still very important today, and maybe in the future AI will replace it along with everything else in the world. But as of now, that is not the case, and AI is simply enabling people who have those engineering fundamentals to be more productive, to leverage it as an assistant, and to do a lot with the fundamentals that they have. It will make useless people who just do like a few-week coding camp and call themselves a software developer and mostly just write code. But if you are designing and engineering systems, AI is making you go to the next level. So this is just some random nonsense I picked about why you should not pick CSE, just joking. But don't pick CSE just because everyone else did. Make sure that you pick CSE because you like coding, or you like designing systems, or you like any of those domains or the different areas that I talked about. Even now, you can try looking into those areas, those domains. There's so much content on the internet, or you can just ask ChatGPT or Cloud Code about the different things. And I strongly suggest you try out a project, a small project, which will maybe set out a day and do a project and see if that's something you like. And I think that's a great way to evaluate whether computer science and engineering is something for you or not. So again, if you don't like to spend that much time on a screen, maybe computer science is not the best place for you, but otherwise it's a great place for you. So some tips: if you do pick CSE, build things outside your coursework, build projects, do your own projects. Like I said, explore different things, find out what interests you. If you do an internship, do it properly. A lot of people in our department get return offers from where they did their internship. Figure out an area. I showed you like 8 different areas. Figure out an area that interests you and learn some in-depth knowledge about that area. Learn the fundamentals more extensively there, and make sure that you are a good communicator. Maybe join some sort of public speaking club like the Gavel Club, and because you need to be able to communicate well with the team, communicate with stakeholders, communicate with customer support, customer relations, forward engineers, investors, everyone, and present what you're working on, what problems you have, or talk to customers, etc. And with computer science, you get the unique opportunity to contribute to open source software, which is public. If you make even a simple pull request on GitHub, anyone in the world can see that you contributed to a public software. So, and you can be a part of that community too. So that's mainly it. I'm not sure if we have time for questions or not. I'll just stop this thing and hand it over to but if you have any questions, you can reach out to me or Navidu, and I'm sure your seniors would also be more than happy to help you. And as always, the department staff will probably be a very good place to find resource persons if you have any other questions before field selection. So yeah, thanks everyone.
Thank you, Mr. Sandil Ranasinghe. With that, we come to the end of this session. On behalf of the Engineering Faculty Student Union, I would like to express our heartfelt appreciation to our speakers for dedicating your time to be with us today. Thank you for sharing your expertise, experiences, and valuable advices with our fellow undergrads. And to all our participants, thank you for joining with us this evening. We hope today's session has provided you with valuable information to help you make an informed decision about your field of specialization. So, thank you everyone and have a great evening.